In high-stakes industrial environments, the most critical factor in any operation is the invisible human judgment guiding the work. An experienced engineer scans a complex schematic and identifies a subtle anomaly that falls outside the scope of a standard manual. This correction is a product of decades of accumulated intuition. Once the task is finished, the project moves forward. But the specific reasoning that led to that correction, the why behind the expert's choice, is lost the moment the deliverable is produced. Businesses currently operate by renting this expertise. They pay for the results of human talent, but the underlying knowledge remains locked within the individual rather than the organization. When the workday ends, that acquired intelligence leaves with the person. Every morning, the company's internal systems essentially reset, having retained nothing from the day before. Organizations have traditionally tried to prevent this knowledge loss by writing static standard operating procedures and lengthy training manuals. This diagram illustrates the gap between the two. On one side is a rigid, linear flowchart. On the other is the organic reality of how experts actually make decisions on the floor. The two rarely align. Most software only tracks whether a task was completed. It captures the timestamp and the outcome, but it remains blind to the context and nuance that the expert navigated to get there. A system that only knows what happened cannot adapt. Without understanding the why behind a decision, the data remains a record of the past rather than a tool for the future. If we revisit that engineer's markup, we can see a different approach. Here, an observant layer tracks the work silently in the background. This is compounding intelligence. An architecture designed to capture the context of an action seamlessly, without requiring the expert to stop or change their workflow. Every markup becomes a data point. A single node forms a precise geometric connection to a larger network, creating a permanent digital pathway. This connection updates the baseline logic for the entire system, preparing it to recognize similar anomalies across the enterprise. The act of doing the work has been transformed. Now, performing a task is the primary mechanism for teaching the system how to improve. This effect scales rapidly. Across a facility, thousands of decisions are being made, like refined quotes, newly reviewed plans, and finalized approvals. Every routine action serves as a continuous data feed. This creates a central reservoir of institutional knowledge that grows with every department's input. The architecture automatically cross-references these actions. It identifies operational connections between departments that are often too complex for manual mapping. This process is inevitable because it requires no extra effort. There is no new software to learn and no manual data entry required from the staff. The intelligence that was once isolated to individual people is now aggregating and multiplying across the entire organization. The organization now functions as a system that maintains and applies its own internal logic. This solves the traditional problem of turnover. In a standard business, when a senior expert retires, their 4 decades of experience disappear. Because their judgment calls were captured by the architecture, the logic they used remains integrated into the company's daily operations. This creates a cumulative library of expertise. By retaining the rationale behind every decision, the organization's total knowledge base persists and strengthens regardless of shifts in the workforce. The era of building business systems based on theoretical processes has ended. Operational intelligence must be built from the actual, lived practice of the people who know the work best. ABQ-AI enables businesses to transform everyday work into systems that learn and improve over time. True intelligence grows from the work itself. ABQ-AI.